Next test is the limit comparison test. It looks kind of like the comparison test, except now we've got a series that we know and a series that we don't know. And what we're doing is we're making a ratio of the two of them, and we're looking at the limit as n approaches infinity. If the limit exists and is a finite number, then both series either converge or both diverge. So when we look at this next one, you see this a sub n term, and we would like to compare it with 1 over 2 to the n, because we know 1 over 2 to the n looks like a geometric series. But this, for the comparison test to work, we would want that inequality. But this inequality is not true, since if we look at the denominators, which fraction is bigger? Well, the fraction on the right would be bigger. Than the fraction on the left. Since the fraction on the left is larger than the one on the right, we have an idea that they look pretty similar. The one on the right converges, but in order for the comparison test to work, we need the convergent one to be larger than the one we don't know. So we're going to use the limit comparison test instead, since we know that 1 over 2 to the n converges. Take the limit as n approaches infinity of, it doesn't really matter which one's on the top and the bottom. So I have 1 over 2 to the n minus 1 here, divided by 1 over 2 to the n here. Taking the reciprocal and multiplying gives me the limit as n approaches infinity of 2 to the n over 2 to the n minus 1. Multiplying the top and the bottom by 1 over 2 to the n gives me the limit 1 over 1 minus 1 over 2 to the n. This limit is equal to 1 over 1 minus 0. 1 over 1 minus 0 is 1. 1 is larger than 0. 1 is finite. So we can conclude that this new series converges. All right, next one, we're trying to determine whether or not it converges or diverges. So this is a kind of a complicated problem. Let's compare it with just 2 to the n squared divided by the square root of 5, square root of n to the 5th. So really we could just look at the largest powers of n. When we take limits of this sort of thing, only the largest powers are going to matter. Now this is 2 to the n squared divided by n to the 5 halves, which is 2 over n to the 1 half. Okay, so this looks like a p series with p equals 1 half. What do we know about that? We know that diverges. So if we get a limit that's greater than 0 and finite, then we will know that the answer is diverges. So we have 2n squared plus 3n divided by the root of 5 plus n to the 5th, all divided by 2n squared over root n to the fifth. Taking the reciprocal and multiplying gives us 2n squared plus 3n over square root 5 plus n to the fifth times square root n to the fifth 2n squared. All right, now let's distribute. We could distribute this out if we'd like, and see what we get. Tell you what, let's do this. Times so we've got our powers here as fractional exponents. So what would we like to do? We would like to multiply the numerator and the denominator by 1 over n to some power. What would that power be? Well, it would be the largest power that we see of the denominator. So I'm thinking we could multiply the numerator and the denominator by 1 over n to the, well, so we have 5 halves plus another 2 is going to be what? Let's see, is that 9 halves? So up top, we have 2 plus 3 over something with n's. I believe that should be 2 halves or just 1. On the bottom, we have a bunch of stuff with n's and square roots. So let's go like this. The square root of 5 plus n to the fifth, I think this is going to be better for us, times 2. I'd like to bring this n, well, I'd like to bring the n squared into the square root. In order to do that, I'm going to have to make that an n to the fourth. Okay, and then in the denominator, I want to bring this n to the 9 halves. That's going to be a n to the 9 under the square root. So I want to be able to combine those together there. What happens when you do that, you'll notice that your n to the fourth and n to the ninth will cancel so that you have an n to the fifth. Then you have a common denominator inside of here of n to the fifth, which we can split this fraction up into 2 pieces. So this gives me the limit as n approaches infinity of 2 plus 3 over n all over the square root of 5 over n to the fifth plus n to the fifth over n to the fifth is 1, and then all that's times 2. Doesn't really matter. Now, when we have our limit, what's going to 0? This is going to 0, that's going to 0, and we're left with 2 plus 0 over the square root of 0 plus 1 times 2. That is 2 over 2 is 1. So we've got our divergent p-series compared with this new one. The limit works out, so this is divergent as well. The end.